So for this problem, to prove these hyperbolic trigonometric functions, then using these identities, so first, we need to rewrite this tangent and secant in terms of sine and cosine using this identity. So for tangent, this is equal to sine over cosine. So this hyperbolic tangent x, this is equal to hyperbolic sine squared x, then over the hyperbolic cosine squared x, then plus for this hyperbolic secant. So since secant is equal to 1 over cosine, so this is 1 then over the hyperbolic cosine squared x, then this is equal to 1. Then observe that these denominators are equal, so we can rewrite this one as 1. So this becomes the hyperbolic sine squared x plus 1 then over the hyperbolic cosine squared x. Then again, this is equal to 1. Then we can use now this identity for the hyperbolic sine and hyperbolic cosine. So for this hyperbolic sine, this is equal to e to the power x, then minus e to the power negative x, then over 2, then quantity to the power 2, then plus 1, then over for this hyperbolic cosine. So this is e to the power x, then plus e to the power negative x, then over 2, then quantity to the power 2. Then again, this is equal to 1. Then to simplify, so for this numerator, in the numerator, using this method, the SMS, so S, the square of the first term, so this is e to the power 2x, then m, multiply these three numbers, so 2 times negative e to the power negative x times e to the power x, so this is negative 2 e to the power x and e to the power negative x, then plus the last s, the square of the second term, so this is e to the power negative 2x, then over this 2 to the power 2, that's 4, then plus 1, then over for this denominator, so again, using this SMS, so the square of the first term, so this is e to the power 2x, then plus, this one is positive, so 2e to the power x, and e to the power negative x, then plus the square of the second term, e to the power negative x, then over the square of 2, that's 4. Then again, this is equal to 1. Then since this 1 is the same as 4 over 4, to make these denominators equal, so therefore this is equal to e to the power 2x, then this x minus x, so take note that multiplying the same base, so we need to add the exponents, so this is 2 plus 4 or e to the power 6. So since the same base and x minus x, this one is e to the power 0 and a to the power 0 is equal to 1. So 1 times negative 2, so this is negative 2. then plus this e to the power negative 2x, then plus 4, then all over 4, then times the reciprocal of this denominator. So this is equal to 4. Then we have e to the power 2x, then plus. So again, this x minus x, this one is 0. And e to the power 0, that's 1. And 1 times 2. So this is 2. Then plus e to the power negative 2x, and this is equal to 1. Then observe that we can cancel now this 4. So this becomes e to the power 2x. Then this is negative 2 plus 4. So negative 2 plus 4, that's positive 2. Then plus e to the power negative 2x, then over this e to the power negative 2x plus 2, then plus e to the power negative 2x, and this is equal to 1. So observe from this equation, the numerator is equal to the denominator. Therefore, this is equal to 1 equals 1.